Hello YouTube fam, welcome back to our channel. In this channel, we will be discussing various topics in the exciting world of AI, machine learning, and computer vision. Our content is crafted by our awesome human team, but here's the magic. It's finely tuned and optimized by our AI wizards, bringing you top-notch information. And guess what? The presentation is delivered to you by our AI hosts and voiced by our incredible AI avatars. Let's get started. In today's video, we will discuss about fine-tuning a LLM. Fine-tuning text generation models can enhance their performance for particular use cases. For example, we can use fine-tuning if we want to modify the tone and format of the output. We can also use it to train based on some proprietary dataset and output the data in a specific format. But before fine-tuning, there are other ways to improve the performance of the LLM. Here are a few of the techniques. 1. We can include more instructions in the prompt. We can provide a lot of details to the LLM. 2. Retrieval augmented generation, RAG techniques. We can retrieve relevant information and augment the prompt. 3. Using LLM to provide chain of thought reasoning. We can ask LLM to reason the thought process before arriving at the final output. 4. Include more samples about the desired output. This helps the LLM to understand what we really want. By the way, if you are interested to know more about RAG or chain of thought reasoning, feel free to check out our other videos. But all the fine-tuning alternatives have some drawbacks. Here are some of the drawbacks. 1. The size of prompt increases. It could be tough to maintain and support. 2. For RAG, we have to depend on some vector store. It could cause some slowness. 3. The number of tokens in the prompt increase. This will incur additional costs. Fine-tuning is an alternate way to improve the performance of the OpenAI LLM. Here we fine-tune the model with our proprietary data prepared in our desired format. Here are some advantages of fine-tuning to improve the performance of the LLM. 1. Fine-tuning incurs an initial cost to tune the model, but once the model is tuned, further outputs can be generated with much less prompting. 2. This also reduces the number of tokens in the prompt and thus saves cost. 3. It could be faster than using techniques like RAG. 4. We can use a bigger proprietary internal knowledge-based dataset for training. All right, let us get some code in to demonstrate fine-tuning. First, let us define our use case. Let us call our custom use case as the Harry Potter spell. Below is our use case. By default, the spells in the Harry Potter series are primarily based on Latin or Latin-inspired words. For our use case, let us say we want to change this behavior. Let us say we do not want Latin words, but we will use English words and add some suffix to them, make it sound like spell words. We will use sentences with 2 words. To convert it into spell word, we will make the first word to be second and the second to be first. We will also add some suffix to the words to look like spell words. For example, throw ball will become bullus throwum, drink water will become water aid, drinkum. Now that we have our use case defined, let us now discuss the steps for fine-tuning. In step 1, we prepare training data. In step 2, we create fine-tuning job and run training. In step 3, we check status and metrics. In step 4, we use fine-tune model for prediction. Let us look at step 1, which is to prepare training data. We need to prepare it in a specific format to be consumed by OpenAI API. It needs to follow the message's JSON format. System role is to specify the way the model answers questions. For our use case, we will set it to, you are an assistant that will answer in Harry Potter spell format. The user role contains the queries made by the user. In our case, it will be sentences we want to convert like throw ball. The assistant role contains the model's responses. In our case, it will be the converted sentences in the format we desire. For example, we will convert throw ball to bullus throwum, drink water to waterade drinkum, play piano to pianist playum, and so on. For our simple use case, we have typed this information manually into the file spelllist.json. OpenAI needs a minimum of 10 such examples. Before we start fine-tuning, let us get the response from the LLM before fine-tuning. When we say throw ball, the LLM responds with actio ball. Let us check why LLM gave the response. When we ask LLM about the origin of Actio ball, it responds as below. Actio is a Latin word that means I summon or I call for. It is a command used within the wizarding world of Harry Potter to summon an object towards the wand wielder. So, this clearly shows that the LLM is using the data it was trained on earlier. After we fine-tune the model, we can see how this behavior changes. All right, let us go to step 2, where we create fine-tuning job and run training. The first thing we need to do here is to upload the training file using client.files.create function. After that, we can kick off the fine-tuning training job using the client.finetuning.jobs.create function. We pass in the uploaded training file and the model we would like to tune as parameters. Let us do step 3, which is to check status and metrics. The command client.finetuning.jobs list will list the fine-tuning jobs. We can look at the current status. Status are like validating files, running, completed, etc. We can also go to the URL platform.openai.com and look at metrics. We can look at how the training loss goes down and converges. If we want better results, we can tweak parameters like number of epochs, learning rate, etc., and submit the training job again. All right, once we are satisfied, we can retrieve the name of the fine-tuned model from either the UI or using the command client.finetuning.jobs.retrieve. For our example, fine-tuned model is named FTGPT 3.5's Turbo-6 Personal 8M38R7U. We will use it in next step for inference. Finally, let us put our fine-tuned model to test. Let us do step 4, which is to use fine-tuned model for prediction. We will provide the same prompt to the default model and to the fine-tuned model. We can then observe the predictions and compare them. For our sample 1, input word is throw ball. The default model responds with engorgio ball, which has Latin words. But our fine-tuned model FTD 3.5 Turbo 061 Personal 8M3X8R7U responds with Ballast Throw'em, which is similar to what we provided in the training file. So we can see our fine-tuning has worked. For our sample 2, input word is sing-song. The default model responds with sonorous, which is based on Latin word. But our fine-tuned model responds with song-sing, which is similar to what we provided in the training file. All right, let us now try with an example which was not in the training file at all. This will further prove that fine-tuned model has learned the pattern we wanted it to learn. For our sample 3, input word is write essay. The default model responds with many sentences with many words from Latin. But our fine-tuned model FTGP 3.5-Turbo-0613 Personal 8M3XR7U responds with SAUS write which is very similar to what we provided in the training file. Of course, this is the pattern we wanted the fine-tuned model to learn. This is what we hoped for when we defined our use case. So in conclusion, we have seen how fine-tuning helped the model to learn our internal requirements and respond accordingly. And there you have it. We have successfully fine-tuned a LLM model to learn our internal requirements and the pattern of the output we desired for. In step 1, we prepared the training data containing spell words for our Harry Potter use case that was in JSON format with different roles needed by the API. In step 2, we created a fine-tuning job and ran training. In step 3, we checked status and the metrics. In step 4, we used our fine-tuned model for prediction. We saw the fine-tuned model respond with sentences like SAUS write ballast throw which is very similar to what we provided in the training file. Of course, this is the pattern we wanted the fine-tuned model to learn. This is what we hoped for when we defined our use case. So in conclusion, we have seen how fine-tuning helped the model to learn our internal requirements and respond accordingly. Thanks for watching. Stay tuned for more exciting adventures in the world of AI and machine learning. If you found this video helpful, don't forget to hit that like button, Subscribe for more tech talks and ring that notification bell to stay updated on our future explorations. Until next time, happy coding and keep the curiosity alive. Thanks for watching. Hello YouTube fam, welcome back to our channel. In this channel, we will be discussing various topics in the exciting world of AI, machine learning, and computer vision. Our content is crafted by our awesome human team, but here's the magic. It's finely tuned and optimized by our AI wizards, bringing you top-notch information. And guess what? The presentation is delivered to you by our AI hosts and voiced by our incredible AI avatars. Let's get started.